So in this video, I'll briefly kind of discuss running a regression in Stata and kind of what the results look like. Okay, so here we are in Stata. We've loaded a data set, an old card data set, and we want to run a regression. So we have, here are all of our variables on the right-hand side. These are the commands we've used. This is the command that we use to load the data set. And so let's say we want to use point and click to be able to run this regression. So if we click statistics, linear models, because it's a linear model that we're looking at, and click linear regression, this window pops up. And this looks like these kind of windows we've seen before in that previous tutorial, where we kind of just need to fill in the information and kind of understand how to do that. So the dependent variable, this is our y variable. So let's say we want to get the returns to education. So the natural log of wage is our dependent variable. And let's say we're trying to use years of schooling to see the returns to years of schooling, basically, the returns to education. So here's treatment of constant. Here's a couple different ways that we can treat the constant. Right now, let's just leave them all blank. So we just want a normal constant. We don't want to get rid of the constant term. We want a constant. We don't want to supply the constant. If we want to just do it for certain groups, or if certain expression is true, then we can enter that in this second kind of tab, place different weights. We don't need to worry about that right now. Robust is, in the future. The default is just going to be homoscedastic errors. If we want to choose to have heteroscedastic robust errors, which we'll talk about later in the course, we can do so with this option here. Okay, so let's just click OK and see what happens. Okay, so we see that it was successful. We didn't get an error here on the top left in the command line. Nothing turned red there. We see that we could have just, if we knew the code, or now that we are starting to learn the code, we could just write this in and do the exact same thing. In fact, we could actually just run reg and then just list the dependent variable followed by the independent variable. So let's kind of talk about some of the output here. Alright, so I just took a quick screenshot just so I can write on the screen. Alright, so here's the number of observations. So here are the number of people in our data set in this case. These first two things in the second and the third items in this list we haven't really talked about in class yet, but essentially what that's doing is running an overall test on this regression, whether all the independent variables have a zero effect on the y variable. So it just automatically runs that test for you in the Stata output. So we have r squared, which we've talked about in class. So here we're explaining 9.8% of the variation in the log of wage through education. Adjusted r squared, which we haven't really got to yet in class, but it's related to the r squared, but slightly different, where it penalizes adding more independent variables. Root mean squared error we briefly discussed, but we haven't really covered too much in this course so far. And then let's move to this top right section. Sorry, I just can't deal with that brown color. So in this section in the top left, it's giving us some information about the sum of squared errors, the sum of squared the model, and the total sum of squared. So this model is saying this is the sum of squared explained. The second one is a sum of squared residual, so the SSR. And here's the total variation, sample variation in our dependent variable, our dependent variable. And we have the degrees of freedom, and the MS is really just dividing the sum of squareds by the degrees of freedom. That's what that last kind of column is right here. We don't need to worry about that too much. Okay, and then down here in this other section of our results, so now we're going to talk about this section of our results. Here Stata is giving us, the estimated coefficient the estimated the standard error, the t-stat, the p-value, and the 95% confidence interval. Okay, let's go by these one by one. So the first thing we see is this first row is this education variable. So everything along this first row relates to this education variable. The second row, underscore const, is referring to the constant. So that intercept, that beta 0, and beta 0 hat, and the standard error of that beta 0 hat, etc., etc. Okay, so what this is saying is 0.052, it's saying that the coefficient, so beta hat on the education variable is equal to 0.052. The second, I guess it's the third column, technically, the standard error. It's just giving us the standard error of that variable. The third column is giving us a t-stat, where the null hypothesis is that this independent variable has no effect on the dependent variable. So what this t-stat is, this t is basically taking the coefficient, so the beta hat, in this case of education, subtracting 0, because it's just automatically testing whether this, testing whether we can say the true value of this, the returns to education is equal to 0. And below it's putting the standard error of this beta hat education. So that's how it's coming up with this 18.15. The next column, 0.000, not actually 0, just a really small number, is telling us the probability under the null that the effect is 0, the true effect is 0, of us getting a t-stat, that far away. So it's telling us there's a really, really small probability that we're committing a type 1 error here if we reject the null hypothesis. And so we're going to use this to form a quick conclusion about whether there's an effect or not. So if you're just trying to test if, education has some kind of effects on wages, or the log of wages in this case, we can just look at this first row and we can do a test of significance really quickly. And the last two columns are just the 95% confidence interval for that coefficient on beta education. Now that next row is that exact same information, but with the constant. So let's just quickly X out of this and go back to our Stata. Get rid of that screenshot. So it's important that we know, and this is like a common mistake that I've seen in the class, is when we want to test whether the true effect of education on wages equals 0, we don't want to use that same command that we were using previously to do a mean comparison test, because that's testing whether the mean of the actual variable education is equal to some number, such as 0 in this case if we made a mistake. We want to test whether the effect of that education on wages, or the log of wages, is equal to 0. So we should not be using that t-test command here to test whether the effect of education equals 0. We should be using the results, or kind of the, this output from the regression to do so. Okay, so like I was saying before, we could do the same thing by just typing reg L wage and education, and we're going to get the exact same output. See, everything's exactly the same. And now let's say we want to move to multiple regressions. We want to have multiple independent variables. So we can always just go back up to our statistics, our linear models, linear regression. Same things pop up, but maybe we want to include some kind of measure. For some reason, I think there's a measure of ability in here, if I'm not crazy. Something else, IQ. It's called IQ here. Okay, let me bring up Stata again, or this linear regression again, and let's add IQ variable here and press OK. So if we want to add more independent variables, we can just list more. Or if you want to be able to type it in, you just type regress or reg, then type your dependent variable first, and then you can list as many of these independent variables as you think should be in the regression, or pick which ones you think should be in the regression. And we're getting the same kind of information. Now there's just a new row with this other independent variable. Now notice that the effects of education have changed a lot here. So that has to do with this kind of simple omitted variable bias that we've been talking about in class, or we will talk about in class shortly. Okay, hope this is helpful for the assignment that's due.